Hi there, this is Penelope, and this is FS3128 Topic 11, Class 1. We only very lightly look at integration, and so there's only 3 classes on this, so we just touch it very lightly, but this is the beginning of Class 1. With most processes in maths, we can have a process and we can have a reverse process as well. What we've got now is we've got a process called differentiation, and we're going to look at the reverse operation, which is called integration. And if we start with something like x squared plus a number, we differentiate it to get 2x. Now, what if we started with 2x? And what if we then asked ourselves, what did we differentiate to get 2x? Well, you should have enough knowledge now to be able to say, well, okay, it must have had x squared in it, because that's how it must have been. And then maybe there was a number there as well. Check. Differentiate that. Yes, we get 2x. So what we've done now is we have integrated 2x. And because we're talking about x, we need to put in that little symbol there, dx. And we're saying the integral of 2x is x squared plus c. Equally as well, this says that the derivative of x squared plus c is 2x. So it's now looking at the reverse operation or the inverse operation of differentiation. What did we differentiate to get 2x? The answer must have been x squared. And we use this symbol together with this bit. We've got to have both bits to say find the integral of. So it's notation. Just to reiterate why we need that c, if we think of it as being a reverse operation and we're checking it and we're saying that the integral of 2x is x squared, it's not enough, because checking backwards, it might have been x squared plus 2, and the derivative of x squared plus 2 is 2x. And it might have been x squared plus 5, because the derivative of that is 2x. So every time we need to put in this arbitrary number, it's called the constant of integration. And usually it's c, occasionally it's written as k, but mostly it's c. So it's just allowing for the fact that there might have been a number there. So we need to write here that the integral of 2x is x squared plus c. The textbook reference there refers to the early edition. For you, if you've got the later edition, it would be page 464. Let's apply the same question to x to the power of 7. What we're going to do is we're going to write that as, what is the integral of x to the power of 7? So what differentiates to x to the power of 7? Okay, it must be x to the power of 8. You reckon? Let's check. Let's check back. The derivative of x to the power of 8 is 8x to the power of 7. So our answer here is actually 8 times too many, 8 times too much. So we need to divide that by 8. That means there's actually a rule that's going to be very helpful. The rule says that if you're finding the integral of x to the power of n, the answer is going to be x to the power of whatever power you had plus 1 divided by the new power. And that makes sense, because if you think of what you're doing when you're differentiating, you are taking 1 off the power and multiplying by the number that is 1 off the power. So to integrate, you add 1 to the power and you divide by the number that is the power plus 1. Now, it's got here, we can't do this for n equals -1. Why not? Let's try it. We've got x to the power of -1. So it's going to be x to the power of 0. That's okay. So far, so good. Over -1 plus 1. Uh-oh. That's where it doesn't work. So that's why it's saying n can't be -1, because otherwise we've got a problem. We can't have that. So as far as you're concerned, mostly we integrate using this rule. This is the general rule, the general formula. Or we've got a table. And the table is in page 435 if you've got the early edition, 464 if you've got the later edition. And sometimes we might just take a look and go, I can make a guess, an educated guess. Maybe I have to refine my guess, but I can make a guess. So that's how we're going to integrate at this level. Here is a table. It's got both the derivatives and the integrals. So for this chapter, we're going to be using this column. For the previous chapter, we used the first column. So you can see it's got some derivatives here. The integral of sine is negative cosine. The integral of cos is sine, and so on. And so there's a list. If you've got the later edition, the list is on page 464. So you just look up the list when we're trying to integrate something. Let's have a look at some examples here. The integral of e to the x is going to be x to the 6 plus 1, which is 7 over 7 plus the constant of integration. E to the x is an amazing one. The derivative of e to the x is e to the x. And likewise, the integral of e to the x is also e to the x. But there might have been a number there, so we have to allow for that. The integral of 8 is a constant. The integral, if you look at your list, the integral of a constant is constant times x. So in this case, it's 8x plus c. When you've got a negative power, you just have to be a little bit careful about what you're doing. It's going to be x to the power of, now, -3 plus 1 is -2 over 2. The integral of cos x, look it up on your list. The integral of cos x is sin x. The integral of 1 over x is natural log x. And look it up on your list. The integral of sin x is negative cos x plus c. What we've been doing on the last slide is doing indefinite integration, and in the next class we'll talk about the difference between indefinite integration and definite integration. But in the meantime, there's my math lab to do in class, there's exercises to do, and for the for those of you with the new edition, it's 36.2, and we'd be looking at page 466. just to reiterate, you don't need to do this during the video. This is the material to do in class itself. It's all very well being able to integrate a single thing, but really the problems that we're likely to find that we need to integrate are a lot more complicated. So we might have the integral of 5 sine x. So the rule here says that we can break that up by putting the 5 out the front of the integral sign and integrate that. Or we might have the integral of 7x cubed. So we can put the 7 out the front and find the integral of x cubed. It's also not very useful just to be able to integrate a single term, so we need to be able to look at something like the integral of maybe these two, 5 sine x plus 7x cubed. So we can split that up into the integral of 5 sine x plus 7 times the integral of x cubed dx, and then we can integrate as usual. Again, I don't want you to do this work when you're watching the video. We will do it in class, but as it's in the PowerPoint slides that you've got, it's useful to have it there. If you've got the new edition, it's 36.3 and the page is 469. And then in class we will do the My Math Lab